All right, now we're going to transform a natural log function. And then I'll show you the natural log function and the log function. You're going to be doing the exact same thing. The only difference is their base is e, but I'm going to show you the transformation on the natural log. All right, so now I have it in the notation that kind of matches more with the natural log. So if there's a value outside of ln, that would be the a value, and a number outside the parentheses would be d, and inside parentheses would be b and c. On this particular graph, since there's not parentheses, you would actually put the parentheses right here. So the 4 is the d, the 3 is the b value, and there is no a value other than 1, and there is no c value. So we won't be needing to do that. I do want to point out that the log and exponentials are inverses. So the exponential has a horizontal, logarithmic has a vertical asymptote at where x is equal to 0. So when there's a shift horizontally, the asymptote gets shifted. In this case, there will not be a horizontal shift, so we don't have to worry about moving that. So remember what we said, the order is you do the stretches and compressions first, then reflection, then shifts. So in this case, you would apply the stretch first, and then you would shift everything up for. Okay, so let's see that would look like. So the stretch got applied first, and then everything got moved up 4. For domain and range, remember logs are the inverse of exponentials, and for exponentials, the domain is negative infinity to positive infinity. So the inverse of that would be the range. And look at that, look at the graph. We start off coming from negative infinity, and even though it curves and is going up gradually, it's still headed towards positive infinity. But as the inverse to the exponential, the range started close to 0 and heading upward. So now it's the domain, since it's the inverse, it gets really, really close to 0, then heads off to positive infinity. And because we did not shift at all, we don't have to worry about, because that asymptote, because there was no horizontal shift, this is still going to be the domain. And the range, regardless of what happens, regardless of how you transform it, this will always be the range for the logarithmic graph. And so here's the regular log graph where the base is 10. You're going to do the exact same thing. Nothing has changed. The only thing that's different, the exponential graph grows a little bit more quickly than the natural log graph. Excuse me, the natural log. This is the ln, this is the log. The natural log graph rises a little bit more quickly than the log base 10 graph. All right, that's it.